Now that we have discussed how to find 2 by 2 determinants, let's go ahead and broaden the scope of our conversation to find the determinant of any sized order. So here we have a 3 by 3 determinant, and what we want to first do is discuss something called the minor. So the minor ij is eliminate the ith row and the jth column of the determinant. So what we're going to do in this example is find the minor 2, 1. So we're going to eliminate the second row and the first column. So if we eliminate the second row and the first column, let's eliminate the second row and the first column, then what are we left with? We have a 2 by 2. So 3, 2, 9, 10. And to find that, well, that's a 2 by 2, and we've discussed the rule. We'll go down and then up. So down gives us 30, up gives us 18. So 30 minus 18 gives us 12. So now let's find the minor 3, 2. So that means that we're going to eliminate the third row and the second column. So minor 3, 2 will be 1, 2, negative 8, 7. So down will give us 7. Up gives us negative 16. And so this is 7 minus negative 16, which is 23. Now, the cofactor is given by the minor times a power of negative 1. So the power on negative 1 is simply the sum of the row and the column for ij. So let's find minor 2, 1 for example 4. So 2, 1 will be second row, first column, and so minor 2, 1 is going to be 3, 2, 9, 10. Go down, that gives us 30. Go up, and that gives us 18. So we have 30 minus 18, which is 12. But that's not our answer. Now we find the cofactor. So a21 is going to be negative 1 raised to the 2 plus 1. Now where did that come from? That's the sum of these two times the number we just obtained. So this is negative 1 cubed times 12, and negative 1 cubed is negative 1, so we get negative 12. So how do we find the determinant for any size determinant? Well, we expand across a row or column, and we tend to choose something that's got zeros in it. And then we find the cofactor for each entry. We multiply each cofactor by the entry that it corresponds to, and then we add all of those results together. Now that's a lot to hear, so let's look at an example. So let's just do something simple, and let's expand across the first row. So this determinant is going to equal one times A11 plus 3 times A12 plus 2 times A13. So I take 1 times its cofactor. 3 times its cofactor, 2 times its cofactor, and I add the results. So now let's talk about those cofactors. So this is 1, and then a11 is going to be negative 1 raised to the 1 plus 1 times the minor plus 3 times negative 1 times 1 plus 2 times its minor plus 2 times negative 1 raised to the 1 plus 3 times its minor. So now, 1 times negative 1 to the 1 plus 1 is 1 times negative 1 squared. That's just 1. Times the minor 1, 1 is a 2 by 2 determinant. And so I'm going to remove row 1, column 1, because I am dealing with 1, 1. So row 1, column 1. So I'm going to be dealing with just 3, 7, 9, 10. Then 3 times the cube of negative 1 is going to be minus 3. And then I have the minor 1, 2. So row 1, column 2 get removed, and we have negative 8, 7, 6, 10. Plus 2, because negative 1 to the 4th is just 1. Times its minor. So we remove row 1, column 3, and we're left with just negative 8, 3, 6, 9. Now these are 2 by 2 determinants, so we can go down minus up. So 3 times 10 is 30. Minus, go up, 9 times 7 is 63. Negative 8 times 10 is negative 80. Minus 6 times 7 is 42. Negative 8 times 9 is negative 72. 6 times 3 is 18, so minus 18. And so what's this give us? 153. So let's find another one. This time we have a 4 by 4. So let's expand across a row or a column that has several zeros. So I see a column that has 2 zeros in it, so let's expand across that. So this will equal 3 times its cofactor plus 0 times its cofactor plus 4 times its cofactor plus 0 times its cofactor. But you'll notice the reason why we go through the business of choosing a row or column with zeros is I don't have to figure out what A22 is or A42 is. So A12 will be negative 1 to the 1 plus 2 times its minor M12 plus 0 plus 4 times negative 1 to the 3 plus 2 times its minor plus 0. So now let's do some scratch mark off to the side and figure out those minors. So M12. M12 will be take the first row in the second column and remove them. So we have 1, 3, 2, -8, 3, 0, 6, 9, 10. Well, that in and of itself is a determinant, so we have to figure out what that is. Now there will be a trick on finding 3x3s that will make this go much more quickly. So let's expand across one of these rows or columns. So let's choose this. So this will be 2 times its cofactor, 1, 3, plus 0 times its cofactor, plus 10 times its cofactor. That's 2 times -1 to the 1 plus 3 times its minor, plus 10, -1 to the 3 plus 3 times its minor. So that's 2 times the minor for 1, 3 would be remove row 1 in column 3, and we're left with -8, 3, 6, 9. Then we have plus 10 times its minor. So 3, 3 would be remove row 3, column 3. So remove row 3, column 3, and we're left with this upper left. So 1, 3, -8, 3. And so this is 2 times -72 minus 18 plus 10 times 3 minus -24. So this is positive 90. So over here we have 3 times -1 times positive 90, and then plus 4 times -1 to the 5th would be minus 4. Now let's find its minor. Minor 3, 2 would correspond to row 3, column 2. So we have 2, 0, 1, 1, 3, 2, 6, 9, 10. And so let's expand across a row or a column. Let's just do row 1. And we have 2 times its cofactor plus 0 times its cofactor plus 1 times its cofactor. So 2 times -1 to the 1 plus 1 times its minor plus 0 plus 1 times -1 to the 1 plus 3 times its minor. So this becomes 2, and the minor for 1, 1 would be remove row 1, column 1. We have 3, 2, 9, 10. And then we have 1 times 1, which is 1, times remove row 1, column 3, and we're left with 1, 3, 6, 9. So we have 2 times go down minus up plus down minus up. And that gives us 15. So that is up here, M32. And so we have negative 330.